Do you remember those days when logging into social media felt like waiting forever? When the internet crawled at barely 1 megabyte per second? It wasn't just slow, it was painful. Every click felt delayed. Every video buffered endlessly. But here's the thing. That frustration, it's exactly what pushed scientists to rethink how the internet should work. Because long before Wi-Fi, before 5G, even before computers were common, someone was already asking a wild question. What if we could send information using light? That curiosity takes us all the way back to the late 1800s to a physicist named John Tyndall. Tyndall wasn't trying to invent the internet, he was studying light. But during one of his experiments in 1870, he demonstrated something incredible. Light could actually bend. He shined a beam through a stream of water, and instead of traveling straight, the light followed the curve of the water. That single experiment proved a principle we now call total internal reflection, the very foundation of fiber optics. At that moment, the idea was simple but powerful. If light can be guided, then maybe, just maybe, it can carry information. Fast forward a few years, and another famous inventor picked up that idea, Alexander Graham Bell. Bell created something called the photophone. Instead of using wires like a telephone, it transmitted sound using a beam of light. He used a mirror that vibrated with his voice, sending signals through sunlight to a receiver. And it worked. For the first time in history, human voice traveled through light. But there was a problem. Actually, a lot of them. Clouds could block the signal, rain could distort it, even slight environmental changes made it unreliable. Bell had proven it was possible, but not practical. So the idea was shelved for decades. In the 1960s, a physicist named Charles K. Kao proposed something revolutionary. Instead of sending light through air or water, why not send it through ultra-pure glass? At the time, people thought it was impossible. Glass had too many impurities. Light would just fade out after a short distance. But Kao believed otherwise. And he was right. By the early 1970s, a team at Corning Glassworks, Robert Maurer, Donald Keck, and Peter Schultz, developed the first practical fiber optic cable using fused silica. This wasn't just an improvement, it was a revolution. Their fiber could carry 65,000 times more information than copper wires, using pulses of light. And here's where things get even more interesting. Fiber optics doesn't just send light, it encodes data into it. Every email, every video, every message you send is converted into tiny flashes of light, on and off signals, traveling through glass strands thinner than a human hair. Inside those fibers, light bounces continuously along the walls, staying trapped due to total internal reflection, the very principle Tyndall discovered. But modern fiber optics didn't stop there. Engineers developed technologies like laser transmitters for precise, high-speed light signals, wavelength division multiplexing, WDM, which allows multiple signals to travel simultaneously on different light wavelengths, like multiple lanes on a highway. Optical amplifiers, boosting signals over thousands of kilometers without converting them back to electricity. This means a single fiber can now carry terabits of data per second. To put that into perspective, that's enough bandwidth to stream millions of videos at the same time. By 1975, fiber optics was already being used in high-security environments like NORAD in Cheyenne Mountain Complex to reduce interference. By 1977, the first fiber optic telephone system was installed in Chicago, carrying hundreds of voice channels through a single cable. And by the year 2000, over 80% of the world's long-distance communication was traveling through fiber optic networks, with tens of millions of kilometers of cable laid across continents and even beneath oceans. Today, fiber optics powers the internet you use every single day. From gaming to streaming to video calls and social media, it all depends on light traveling at incredible speeds. Not quite the full speed of light, but close enough to change the world. And it all started with a simple question and a beam of light bending through water. So next time your internet feels slow, just remember, we went from sunlight experiments to global light speed communication. That's not just an upgrade, that's a revolution. And who knows, the next breakthrough might already be in someone's curiosity. If you enjoyed this breakdown and want more stories like this, hit that like button and subscribe, because the science behind everyday tech is way more insane than it looks.